Hi everyone. Okay, before we start today, I want to know from you people. I will ask you some simple questions and I want your response based on physics. Okay, just to ensure कि आपको कॉन्सेप्ट्स क्लियर है या नहीं. तो अगर मैं आपसे पूछूं कि सूडो फोर्स कब लगाते हैं, हम किसी भी बॉडी पे सूडो फोर्स कब लगाते हैं, तो व्हाट विल बी योर आंसर? बताइए. When do we apply pseudo force, imaginary force, एंड हाउ मच इज, अगर कोई एम मास की बॉडी है जिसे ऑब्जर्व कर रहे हैं हम, तो उस पे सूडो फोर्स लगानी है, तो वो सूडो फोर्स होती कितनी है, वो सेकंड पार्ट है. पहला पार्ट है कि सूडो फोर्स क्यों लगाते हैं, कब लगाते हैं. हु विल रिप्लाई? यू कैन. डोंट नो. ठीक है नवीन, अभी मैं एक्सप्लेन करूंगा. एनी अदर चाइल्ड हु कैन टेल मी why do we, what is pseudo force, how, when do we apply pseudo force and कितनी. ठीक है. सूडो फोर्स आपने विजुअलाइज तो कर लेंगे आप. हाँ, नॉन इनर्शियल फ्रेम. अरियम अरहम शाह. व्हेन द ऑब्जर्वर इज इन अ नॉन इनर्शियल फ्रेम, जो बॉडी है वो कहीं भी हो, अगर ऑब्जर्वर नॉन इनर्शियल फ्रेम में है, यानी कि वो एक्सेलरेट हो रहा है, ऑब्जर्वर एक्सेलरेट हो रहा है, तो हम सूडो फोर्स अप्लाई करते हैं. और उसको मैं समझा देता हूं. आपने अगर मैरी गो राउंड में आप वो घूमे, झूला आपने वो घूमा होगा, उसमें तेजी से हम घूम के ऊपर चढ़ जाते हैं, तो मैरी गो राउंड में हमें एक फीलिंग आती है कि हम बाहर की तरफ गिर रहे हैं. तो क्या हम पे एक्चुअल में कोई फोर्स लग रही होती है बाहर की तरफ, या फिर वो जस्ट एक फीलिंग है? वी फील दैट वे. और हम, आई गॉट इट. हाँ, करेक्ट. अगर आप सब लोग चैट पढ़ पा रहे हैं, तो अरम ने लिखा है सूडो फोर्स. अरम, यू आर अ वेरी ब्राइट स्टूडेंट. सूडो फोर्स इज टू बी अप्लाइड जब ऑब्जर्वर किसी एक्सिलरेटिंग फ्रेम पे बैठा हुआ है. अगर फ्रेम ऑफ ऑब्जर्वर की एक्सेलरेशन है, तब हम सूडो फोर्स लगाते हैं, और उसकी वैल्यू होती है मास इनटू एक्सेलरेशन ऑफ द फ्रेम. मास ऑफ द बॉडी बीइंग ऑब्जर्व्ड, जिस बॉडी को ऑब्जर्व कर रहे हैं, और एक्सेलरेशन ऑफ द फ्रेम ऑफ द ऑब्जर्वर. और ऑपोजिट डायरेक्शन में होती है, ऑपोजिट टू द एक्सेलरेशन ऑफ द फ्रेम. ये डी एलम्बर्ट ने ये प्रिंसिपल दिया सूडो फोर्स का. और अगर हम सूडो फोर्स नहीं अप्लाई करें, तो सूडो फोर्स ना अप्लाई करने पे न्यूटन्स लॉज ऑफ मोशन विल नॉट बी एप्लीकेबल. चलिए, अब मैं आपसे एक सिंपल क्वेश्चन पूछने वाला हूं. अगर मैं ईस्ट की तरफ भाग रहा हूं, इफ आई एम रनिंग टुवर्ड्स ईस्ट, द फ्रिक्शन फोर्स ड्यू टू द ग्राउंड ऑन मी विल एक्ट इन विच डायरेक्शन? क्विक. ईस्ट और वेस्ट? इफ आई एम रनिंग टुवर्ड्स ईस्ट, the ground's friction force which is acting on my feet is in which direction? This is the question. Just checking your, ये oral test है. This is your oral exam that I'm taking of your concepts. Let me see how many of you are conceptually strong. If I'm running towards east, the friction force applied by the ground is in which direction? Okay, nice, good, 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 good. Very good, very good. Quite a few of you are clear. Many of you, almost all are clear. Your answer is right. East. Good. Newton's third law. Next question. Newton's third law. To every action, there is equal and opposite reaction. Action and reaction forces are equal and opposite. Do they cancel each other? This is the question. Yes or no? No, because they are acting on two different bodies. Action and reaction forces are equal and opposite, but they don't cancel each other. And from there, you get clarity about free body diagram. Good. Now I am going to ask you another question. If suppose I have a pen, which is this pen is doing this motion. It is translating, pure translation. The orientation is not changing. Such a motion is called pure translation. Yes or no? ऐसे चले जा रहा है ये. So this motion is pure translation. Yes or no? Good. If the center of mass of the body is fixed and it is just rotating like this, is it pure rotation? Yes or no? Every one of you should know this. Yes. It is pure rotation. If the center of mass is fixed, it is pure rotation about center of mass. Yes. If I fix this to a hinge and make it rotate like this, ऐसे, ये hinge fixed है यहाँ पे और ऐसे rotate कर रहा हूं, तो is it pure rotation about this hinge? Yes or no? Hinge is not moving. ऐसे, ये rotate कर रहा है about this hinge. So it is pure rotation about that hinge. Yes, correct. Now, if a body is moving like this, देखिएगा ऐसे, is it doing translation as well as rotation or not? This pen is doing translation as well as rotation. Yes, correct. Correct. Good. Now, there is a thing called superimposition theorem. If suppose it is moving, this is very important and I just wanted to highlight because it is generally neglected. If this body is moving with a velocity VCM, its center of mass is moving with VCM. So every point of this body is moving with velocity VCM in the same direction as the pen is moving. Okay. If the pen is rotating about its center of mass, ऐसे ये rotate करे जा रहा है, तो rotate कर रहा है तो उस situation में each point has a different velocity. इसकी है L/2 इंटू ओमेगा. ये देखिए इधर इस पॉइंट की वेलोसिटी L/2 इंटू ओमेगा. सेंटर ऑफ मास की है 0 और कोई जनरल डिस्टेंस x पे जाऊं तो ये जो डिस्टेंस है x, वो वेलोसिटी इस पॉइंट की वेलोसिटी होगी x ओमेगा इसी डायरेक्शन में. सो हर पॉइंट की डिफरेंट वेलोसिटी है और वो रोटेशन की वजह से है r ओमेगा. ओके. अगर दोनों चीजें हो रही हो, VCM से चल रही हो और ओमेगा CM से रोटेट कर रही हो, तो उस सिचुएशन में आप क्या बोलेंगे? यू विल यूज सुपर इम्पोजिशन प्रिंसिपल टू फाइंड द नेट वेलोसिटी. You will use superimposition principle to find the net acceleration also. और वो सुपरइम्पोजिशन प्रिंसिपल मैंने आपको बताया हुआ है और अब मैं आपको उसको ड्रॉ करके क्विकली बता देता हूं क्योंकि हमारी बहुत सारी कंस्ट्रेंट की इक्वेशन वहां से आती हैं. आई विल शो यू फ्यू quick questions and that will give you a lot more conceptual clarity. Okay, just yes, correct, Aram. I was waiting for the tab to be connected to the laptop, and I was trying to utilize that this time by asking you questions so that the interaction, the response gives me clarity ke how many of you are sincerely understanding what I'm teaching. And now I am in next 1 minute getting connected to the tab and starting my lecture. Now, ready? चलिए, अब सब लोग रेडी हो जाइए. एंड आई विल बी डूइंग की कॉन्सेप्ट्स फर्स्ट. लेट्स डू मोर प्रॉब्लम्स ऑन मैकेनिक्स, देन वी कैन मूव ऑन टू gravitation, and from gravitation we'll jump to electrostatics and then electricity and magnetism, because these are very very important chapters. Now, starting I keep it like this. चलिए शुरू करते हैं. So if there is a rod, this rod is having a velocity in this direction, VCM, center of mass is moving with velocity VCM, and suppose this rod is rotating with angular velocity omega cm about center of mass, then the net velocity of this point will be, due to translation, it will be VCM. Due to rotation, it will be in the same direction, and it will be L by 2 into omega cm. For this point, the translational velocity will be VCM. The the velocity of this point due to rotation will be in opposite direction, and that will be L by 2 into omega cm. And here they will get added. VCM plus L by 2 into omega cm will be the net velocity of this point. For this point, it will be VCM minus L by 2 into omega cm, whichever is higher. For any other point, you can find out the velocity here. How will you find out the velocity? VCM due to translation. And if this perpendicular distance is d, then due to rotation, it will be d omega in this direction. And net velocity of this point will be VCM minus d omega cm. Okay. So you know all the points of this rod are having different velocity. This point has only VCM. This point has this velocity. This point has this velocity. And you can find the velocity of any point using the superimposition theorem. All of you should get clear about it. Now, similarly, you can have the same theorem for acceleration also. Now, if I tell you this body has angular velocity omega also, and it is having an angular acceleration alpha also, ऐसे, and it is VCM and it has an angular linear acceleration like this, ACM. It is not necessary that A and V have to be in the same direction. It is not necessary alpha and omega have to be in the same direction. But right now, omega and alpha, I am saying, are in same direction. VCM and ACM are in different direction. Now if I ask you one question, and that question is this point, what is the acceleration of this point? I want a perfect answer from all of you. What is the acceleration of this point? Can you put it on charging? What is the acceleration of point P, this point of the rod? This rod is moving with this velocity, this acceleration, angular acceleration is this, omega, angular velocity is this. All these four quantities are known, given. You have to tell me what is the acceleration of this point P, lowest point of the rod. I mean, I want to see how many of you write it correct. Current electricity is weak और हम चलिए आज इलेक्ट्रिसिटी पे ही जंप कर जाएंगे. चलिए बस ये कर दूं, सुपर इम्पोजिशन प्रिंसिपल अच्छे से आपके दिमाग में बिठा दूं. लेट्स सी. सो इट विल हैव एन एक्सेलरेशन ACM. जो ये ACM है, इतनी एक्सेलरेशन इस पॉइंट की ट्रांसलेशन की वजह से होगी इन द सेम डायरेक्शन, ACM. And due to rotation, it will have angular acceleration alpha है, तो tangential acceleration will be perpendicular to, ये देखिए ये angular acceleration है, तो perpendicular direction में it will have L by 2 into alpha cm. This will be the tangential acceleration. This is translational acceleration. This is tangential acceleration. These two are vector quantities. This has this direction, or this acceleration has this direction. And vector sum of these two will be the answer, or there is something wrong. Just write down, will the vector sum of this and this will be the answer, or there is something wrong. So write wrong or correct. Just type, is it correct to say that this and this vector on addition will give me the net acceleration of this point? Is it correct or is it wrong, or something is missing? Quick. फंस गए आप. Wrong. Wrong, wrong, wrong. Yes, Masira is right. Missing. Yes, Amina. Arey, bhai, aap to, all of you are good students. Lavanya got it. Yes. There is a third acceleration, and that acceleration is in this direction, this one. Due to rotation, this rod is rotating about its center of mass with angular velocity omega, and it will have a centripetal acceleration also. And that will be L by 2 into omega square. These three vectors, when added, will give you the net acceleration of this point. Never miss out on this acceleration, please. So you will have translational acceleration, you will have tangential acceleration, you will have radial or centripetal acceleration, and the vector sum of all these three vectors will give you the net acceleration of this point. Get this clear. This is again a concept where you have to have clarity. Now I can frame a lot of numerical values can be put and I can give you questions. Now let's move. So when you have questions like these, that it is a block on which a sphere is rolling, the sphere has a velocity vcm, it has an angular velocity omega cm, and this has a velocity v2. Can you tell me what should be the relationship between, and it is kept on a horizontal frictionless surface? Okay. Suppose they have these velocities. What will be the condition of pure rolling here? Will it be r is the radius? Will it be v cm is equal to r omega cm? Is it correct? Yes or no? Is it correct? Yes or no? Yes or no? That's it. I have mentioned VCM will be equal to, one second, R omega CM. True or false? Lavanya wrong. Dania Basra wrong. Wrong. Very good. Mahantesh, good. Those of you realize that this is not the correct answer. VCM is equal to R omega CM is not always true. Condition of pure rolling will be arrived at. How do we get that condition of pure rolling? If this is doing pure rolling, the point of the sphere which is in contact, I am naming that point as 1. And the point of the plane which is in contact, I am naming that point as 2. If point 1, velocity of point 1 is equal to velocity of point 2, then they are not slipping with respect to each other. Then the sphere is doing pure rolling. So the condition of pure rolling is this: velocity of these points of contact has to be same. Velocity of this point and velocity of this point, they have to be same. The pink and the red point, which is in contact. Now, how do I find the velocity of 2? Velocity of 2 is known to me. Velocity of 2 is v2, because this body is moving with v2. So every point of this rigid body is moving with velocity v2. So point 2 is moving with v2. Okay. How do I find the velocity of point 1? Velocity of point 1 will be found by superimposition theorem. Using superimposition theorem, I'll say velocity of this point should be in this direction. It should be vcm. And due to rotation in this direction, clockwise, the tangential velocity will be r omega cm. So the net velocity of this point 1 will be VCM minus R omega CM, and that should be equal to V2. This is the condition of pure rolling, and this is not the condition of pure rolling. How many of you got clarity on this? How many of you understood this? Give me a yes. Write down yes. Good. Keep paying attention. All these things you will find in your paper when you will appear for any competitive exam. Concepts are modified and put in the form of questions. So if you are conceptually clear, you will be able to answer questions. And because we have less time, I want to focus more on concepts and less on solving questions. Okay. Now we have understood this. Now it has a lot of applications in a lot of questions, whether it is a collision question where you have a rod is colliding with another ball, or you have a disc colliding. Okay, chalo, let's do 1 minute. We did such questions on collision. Now let me do some questions on free body diagram. Okay. Okay, let me give you a simple question. A tough question, a challenging question, just to check how many of you are strong in your concepts. This is one question which gives me full clarity about a child's ability and conceptual clarity. Let me see, let me check how many of you will impress me with this. I will feel really happy and I'll become a fan of you if you do it right. So be very, very clear. This is an inclined plane. It will involve few concepts of mechanics, and only if you are a good student you will be able to solve this. This is a horizontal plane which is frictionless. This is a wedge of mass m, big M, and there is another sphere which is kept on. Oops, why is it like this? Hmm. This is a sphere. Hmm. This sphere is kept on this plane, and the sphere is in touch with it, and there is friction here. There is friction force on the inclined plane. Friction is there. So this sphere will fall down doing pure rolling. This is given. It is doing pure rolling and falling down. The mass of the sphere and the radius of the sphere is small m, small r. This is big M, the wedge. And the wedge is kept on a frictionless horizontal surface. So if I leave this sphere, it'll fall down. Friction is sufficient enough that pure rolling is happening. Pure rolling is happening. You have to tell me what is the acceleration of the wedge. This is the question. If any one of you can do this, make a correct free body diagram and mark all the forces, I will be royally impressed. Then you are a very sincere, very intelligent, and very conceptually strong child. I will solve it after exactly 1 minute. So in this 1 minute, try to make the free body diagram quickly and try to mark all the forces and write the equations involved. Let me see. The wedge is free to move. The wedge is also sliding on this horizontal surface. You have to tell me what is the acceleration of the wedge. This is the question. Try to do it. I will keep asking you questions, then you will respond. First, give it an attempt on your own. And then, if you have attempted, even if you are wrong, there will be a lot of learning here. And let's see what we learn from this. They are in contact. It is rolling on this. Pure rolling is happening. It is falling down due to gravity by pure rolling. We have left the system free from rest. You have to tell me the acceleration of the wedge. Big M. try to give it an attempt. Give it a give. Try to attempt it. Try to solve it. Okay. Now, while solving it, I will be asking you questions and you have to be on your toes. It's going to come messy. I think you can tell I can tell you the equations. Okay, Aram. I will be impressed. Keep answering my questions. I will judge whether you knew it or not. I have my first question here. I am going to mark all the forces now. So, one force is mg, which is acting on the center of mass of the wedge, big mg. Another force is small mg, which is acting on the center of mass of this sphere, small mg. There is a contact force between these two, which is acting like this and like this. Let me name that as N. Even though there is a contact force here also, but this contact force will not play much of a role because there is no friction here. But I'm writing it as an N2. Okay. These are the forces which are acting. There is a friction force also, and that will be static or kinetic. Just answer this. Okay. I had done a similar question. Yes. Where there was here, there are rotation is also involved, and I agree. Huh. mg sine 2 theta by 2m. Adarsh Tiwari. Okay, let's see. mg sine 2 theta. Adarsh, just be attentive. Let's see. Um, hmm. So my question is, still people make mistakes and you will know why I'm saying that. So these are the forces which are acting. There is a friction force also. That friction force I am going to mark here. That friction force, suppose, is that is static or kinetic? Just answer that. Which force is acting? Kinetic friction force or static friction force? When it is doing pure rolling friction, which is negligible, it is there. But static friction or kinetic friction? Yes. Khalida, very good. Static friction. I am assuming in case of static friction, you have the liberty, you can assume whichever direction you want to, and still you will get the right answer. But right now, I am assuming friction static force Fs is acting on it in this direction. It will exert an equal and opposite force on this direction. Fs. First question is because mu s is variable, so you cannot, unless you are given the value of mu s, you cannot know friction. Now, my question is this angle is theta. This angle is theta, inclined plane. If this is theta, this will be 90. This is 90 minus theta, 90 minus, this is theta. Okay, everyone knows this. Now, my question is the component of mg in this direction will be mg cos theta. And the component of mg parallel to the plane is mg sine theta. Okay. Now I have drawn these two forces as components of mg. So let's get rid of mg. We have broken it down into parallel to plane and perpendicular to plane. The reason these two directions are important for us now is because we know the motion is happening for the sphere down the plane and perpendicular to the plane. Okay. Now my question to you is n equal to mg cos theta? First question. True or false? Is First question is n is equal to mg cos theta. True or false? Lovely. Impressive. mg cos theta ke it won't be equal to mg cos theta. It would have been if this wedge was fixed, then it would have been equal. It is not equal. Correct. Those who said true, they need to understand why. Okay. Now I have this thing. So I am assuming it has an acceleration. It has an acceleration down the plane, some acceleration A1. Does it have an acceleration perpendicular to the plane in this direction? A2. Does it or not? And this is A3, suppose. A2 is 0, true or false? Is it true or is it false? Acceleration of the ball perpendicular to the plane, is it 0 or is it non-zero? Khalida, this is not true. It is not 0. Adarsh, it is not 0. It has an acceleration perpendicular to the plane. So it is not true. Yes, yes. So acceleration is not equal to 0. This is false. It has acceleration. Okay. Now, if we want to do this question, we can do it. We can stand on the ground and then observe it and write the equations. If I am standing on the ground and writing equations, I will see this wedge has an acceleration A3 and this sphere has an acceleration A1 parallel to the plane, A2 perpendicular to the plane, and angular acceleration alpha about the center of mass, alpha cm. If I observe from the ground, if I observe, okay, now will come. So do I need to apply pseudo force on the sphere or I can write equations from the frame of the ground? So I'll frame the question. You have to tell me, can I solve this question without applying pseudo force? Yes or no? If I observe everything from the ground frame, do I need to apply pseudo force? Yes or no? Should I apply? This is the question. Should I apply pseudo force on this sphere or not? Observer is here on the ground. Quick. No. No. Wrong. You will not, the observer is standing on the ground. This is the observer. And if a observer is in an inertial frame, which is the ground frame right now, I don't need to apply any pseudo force. No. No is the answer. Yes. If we sit on the wedge and then write the equations, then we will apply pseudo force. Okay, we'll come to that part. This is the funda that everyone should be clear. Okay. Now quickly answer this. If I want to do it from this frame, I will write down the equation of the wedge in this direction. I will break n in this direction and perpendicular direction. This will be theta, n cos theta and n sin theta. Okay. So for the wedge, if you will see, there is only one horizontal force, and that is n sin theta for the wedge. And I don't know the value. Value of n is not equal to mg cos theta. Please be sure. So one equation you'll write n sin theta is equal to big M into A3. Okay. There is no other horizontal force acting on big M. For the sphere down the plane, we'll write down mg sin theta minus friction force is equal to mass into acceleration of the A1. For this direction, perpendicular to the plane, this direction, we will write mg cos theta minus normal reaction N1 is equal to mass into A2. And net torque about center of mass will be mg is passing through that, so torque due to mg is 0. So it'll only be friction force into R. Net torque is equal to I alpha. You already know for a sphere, solid sphere, suppose I say alpha cm. Okay. I have got 4 equations and I've got 5 unknowns. What are those 5 unknowns? A1, A2, A3, alpha and normal reaction and friction force. 6 unknowns. 1, 2, 3, 4, 5, 6. I need two more equations. Fifth equation will come from this is 1, this is 2, this is 3, this is 4, this is fifth equation will come from the point of contact. So we will find the acceleration of these 2 points in the direction parallel to plane and equate it, because there is no slipping happening between these two in this direction. So the acceleration parallel to the plane should be equal, and acceleration perpendicular to the plane should also be equal. So the next two equations that you will get will be acceleration of this point will be of the sphere will be a1 minus r alpha cm. Acceleration of this point of the wedge will be, it is a3 in this direction. So a3 in this direction. So a3 as a component perpendicular and tangential like this. This angle is theta. A3 cos theta. This should be equal to minus a3 cos theta. This is one equation, and perpendicular to the plane will be another equation, which will be, sorry, बहुत lengthy question हो गया, थोड़ा tough है, but just bear. So mg, the perpendicular direction will be a2 should be equal to a3 sin theta 3. Sin theta. These are the 6 unknowns, 6 equations you will solve. Here we didn't apply any pseudo force and we observed everything from the ground frame. Now, if we would have gone and sat on this wedge and observed this body falling down, so then we would apply a pseudo force and then we'll use that force. Okay, I have a question. Let me see how many of you are conceptually very clear. The same wedge, the same sphere, and this is big M, this is small m, this is radius r. I am going to sit here and observe this sphere falling down. What will be, will I be applying a pseudo force? Yes. Suppose this has an acceleration a3. This will have an acceleration parallel to the plane is a1, and it will have an angular acceleration alpha cm. And when I'm sitting here and observing, I will find this acceleration to be how much? Quick. It'll be 0. I will not see this acceleration at all. And this A1 will be different from previous A1. This will be A1 dash will be acceleration of small m with respect to big M. This will be the acceleration. And this is going to be different from the previous A1 which we were using down the plane. This A1 is different from A1 dash. Get this. Because now we are observing everything from this frame, sitting here. Now I have a question. I will have to apply a pseudo force on this. How much pseudo force? Quick. Mass of the body being observed into acceleration of the frame of the observers, and direction has to be opposite. So it will be MA3. This will be the pseudo force. Okay. We will treat that as a force, and you will have mg, normal reaction, all other forces will be there as it is. Write the equations. Now, do I need to, if an observer is sitting here and observing everything, do I need to apply a pseudo force on this body? Please answer yes or no. On the wedge also. Give me an answer. Yes or no. Arham says no. Manju says yes. Khalida says yes, 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 yes. Yes, you have to. You will be applying a pseudo force on this also. This shows, oh, some of you are really good students. I'm very, very impressed. You will have to apply a pseudo force on this wedge also in opposite direction. Big M into A3. And now when you will observe everything from here, What will be the acceleration of this wedge that will appear for this observer in horizontal direction? What acceleration will he see? Just tell me. Acceleration of the observer who's sitting on the wedge. What acceleration will he find for the wedge? What is the wedge acceleration relative to a person who's sitting on the wedge itself? Zero. Yes. So, correct. So, pseudo force, because the observer is sitting in a non-inertial frame, any body you will observe, you will apply pseudo force on. You will apply pseudo force on this block also, this sphere also, and this block also. Sometimes some people observe this sphere motion from here and they will write the equations for this wedge from ground. That is also acceptable. But then you don't need to, if for the wedge you are writing equations standing on the ground, then you don't need to apply pseudo force. But if you are observing the wedge from here, from the wedge, then you have to apply pseudo force. You have to be crystal clear in which case what you have to apply or not apply. Okay, anyways, you are with me in the thought process. I am happy. We are getting clarity. Now, let's move. Now, let's come to, because I know 12th topics are generally done in a hurry. Mechanics, you are doing your whole 11th, you get enough time. Now, let's come to gravitation. And gravitation is extremely important because same thing is there in electrostatics. So I will be doing electrostatics chapter and gravitation chapter both in parallel. The only difference will be here you have masses which are only attracting each other. There you will have, and mass is always positive, I mean M1, M2, and they will only attract each other. In electrostatics, you will have charges which are positively charged and negative, positive and negative charge. And you will have attraction and repulsion both. That is the only difference. Otherwise, everything else will remain the same. Okay. So let's do quickly gravitation and electrostatics parallel. Gravitation. I will ask you some questions on this chapter now. Alert. And assuming that I'm not going to teach everything from scratch, I will touch upon the key concepts. Let me ask you a question. If suppose this is a hollow shell, this shell has mass m, hollow ball, radius r, and there is another point mass which is at a distance d. This is a point mass which is m2. This is m1. What is the force of attraction between these two, this ball and this point mass m2? Force of attraction between this point mass and this ball. They will exert a gravitational pull on each other. They will attract each other. What will be that force? Will that force be G m1 m2 upon d naught square? Yes or no? Correct. 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 Yes. Now, if suppose I take this point mass m2 inside the shell and I keep it here at this point position, what will be the force which will be, this is r by 2. What will be the force acting on m2 if m2 is placed here inside this shell? यहाँ से हटा के I am placing it here. Now tell me what is the force acting on this m2 due to the shell? Very good, Aram. It will be 0. 0. Good. How many of you know this? So the gravitational force, gravitational field inside the shell due to the shell is zero. All of you should know this. Same is with charge. If Q is the charge, then the electric field inside, whether you talk about gravitational field or you talk about electric field due to a charge, both will be zero inside a shell. Okay. And you can actually find that out using integration, but you should know this result properly. Okay, let me start with a very basic question. Suppose this is Earth. Oh, when you do gravitation chapter, the very first thing, okay, all of you, this is a very conceptual thing which people don't understand. All of you must have heard that day and night is caused due to rotation of the Earth. True or false? Quick reply. Day and night is happening due to the rotation of the Earth about its axis. True or false? True. True. Correct. I can see the participation. I am reading your answers. True, true, true. Good. Ninad. Very good. Now comes the beautiful question. The question is change of seasons. गर्मी और सर्दी और जो होता है change of seasons is due to revolution of the earth. True or false? Change of Khalida Tabassum. True. The change of weather seasons is सर्दी और गर्मियां जो आती हैं, this is due to revolution of the earth in its orbit around the sun. Okay. Lovely. Lovely. Correct. Everyone knows these two things. Very simple. Now I have a question. The question is this. This was to know whether you know things till here. Now the question is this. And Kepler's laws, everyone knows that if there is an ellipse, the planet follows an elliptical path with sun at one of its foci. So अगर sun यहाँ पे है, ये रहे, sun को मैं एकदम ये बना दिया, ये फोकस पे है, F1, F2, ये फोकस पे sun है, ये लीजिए. और अब अर्थ को मैं बना देता हूं ब्लू. ये अर्थ है. तो अर्थ अब हाँ. सो when is the weather going to be cold on the earth? यहां पे एक मिनट. इस पोजीशन को मैं बोल रहा हूं 1. इस पोजीशन को मैं बोल रहा हूं 2. इट इज क्लोजेस्ट हियर टू द सन. Sun is here. Please get this clear. This is sun at one of the foci. And this is earth, planet earth. And earth पे when earth is at one, position 1, उस वक्त विंटर्स होंगी या समर्स होंगी? विंटर्स होंगी, मैं ये बोल रहा हूं. ट्रू और फॉल्स? हाउ सिंपल अ क्वेश्चन आई एम आस्किंग. When earth is farthest from the sun in the elliptical path, at that time, at that position, the earth is here, position 1. And when it is at position 1, earth will have winters. True. And when earth is at 2, you will have summers. You will have very hot. It is close to sun. True or false? Quick. फंस गए आप लोग. फंस गए आप लोग. I trapped you. Your answer is wrong. Now, understand what is wrong. And this funda is not clear to a lot of students. Understand this. So I will tell you the story behind this question and then the concept. Okay. Understand this. Earth, I am going to draw it as a big Earth. This is Earth. Earth has summers in this half and winter here. It is not जिस वक्त इंडिया में गर्मी पड़ रही होगी ना, उस वक्त अमेरिका में सर्दियां होंगी, और जिस वक्त वहां पे सर्दी होगी, यहां गर्मियां चल रही होगी. सो प्लीज ट्राई टू अंडरस्टैंड. इट डजेंट हैपन कि पूरी अर्थ, द होल अर्थ इज नॉट हैविंग विंटर्स एट दिस पोजिशन. द सदर्न हाफ एंड द नदर्न हाफ both have summer and winter, and one half is having summer, the other half is having winter. So you cannot say it is winters on the whole earth here. Same here, when the earth is at this position, one half is having, this half is having summer and this half is having winters. So it is not. So now how do you explain? You were telling me that it happens due to the revolution of the earth around the sun, and that decides when will be summer, when will be winter, and all of you agreed to this, that this is true, and you agreed to this is true. But I am saying this is not true, because half of the earth has summer, half of the earth has winter here also, half of the earth has summer and winter here also. How do you explain this? Okay. Hmm. Now, now understand. I asked the same question to my teacher when I was in 12th, physics teacher. Hmm. So I asked him the same question, and I didn't get a satisfactory answer from the teacher. And he just gave me a hint. Okay, if this question comes, you just write down it happens due to the tilt of the earth. This should be the answer. So if this question comes in the exam, just write down tilt, due to tilt. The summer and winter is not decided due to the bhai, how do you, can anyone explain, have you understood the situation problem what I'm asking you, and can now anyone give me clarity what is happening, what happens, and this is actually the correct answer. Now let me tell you. So in school, teacher told me tilt लिख देना और marks मिल जाएंगे. I also wrote in the exam, school exam, that it happens due to the tilt of the earth. The axis is tilted. The axis of rotation of the earth is tilted. So, and the change of weather is happening because of that. The one, the southern hemisphere, the hemisphere which is due to the tilt towards the sun side. But yeah, this distance, elliptical path, it appears to be like unbelievable. Okay, this distance is very less, and this distance is very large in the ellipse. So when Earth is far, then it should be cold, very cold here. When it is close, it should be hot here in this situation. This is very contradictory to what you have learned. Can anyone explain? No, I'm not. Nahi, nahi, Lavanya. Light is invariably. Who will explain? Hmm. Who will explain? Okay. So we forgot this one day, just few years back. Me and one of my batchmate friend, school friend, he did his IIT also. He did his IM Lucknow MBA also. We were in Haridwar together, sitting on a full moon night, on the bank of river Ganges. And he said, you are a physics teacher. I was teaching my daughter. He was telling me. And she asked me this question, and I was not able to answer. Can you give me clarity on this? Yes, 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 yes. So then I thought about it. That is when I थोड़ा सा सोच के फिर मुझे मैंने डिस्कस किया और फिर मुझे फुल क्लैरिटी उस मोमेंट पे आई व्हेन आई वाज ट्राइंग टू एक्सप्लेन इट टू हिम एंड आई वांट ऑल ऑफ यू टू अंडरस्टैंड दिस सो प्लीज अंडरस्टैंड दिस इफ यू गूगल you will find the eccentricity. I'm sure in maths you must have learned eccentricity. What is eccentricity? So for a circle, eccentricity is how much? One. Is it one? For a circle. For a circle, is the eccentricity equal to 1? Yes or no? Children, please tell me. What is the eccentricity of a circle? Zero. Eccentricity is zero. Now just find out the eccentricity of the Earth's orbit around the sun. This is the value. 0.0167. What does that mean? Eccentricity for a circle is zero. Eccentricity for an ellipse, Earth's elliptical path is 0.06167, which means it is almost like a circle. So this ellipse is almost like a circle, and the perception that we carry, it is an elliptical path, but that ellipse is eccentricity is almost tending to zero. So it is almost like a circle, and it is not the distance which is making the difference. It is the axis of the earth is little tilted of rotation, and because of that, this is the position here. Now, the sun is here, almost at the center. Here you'll find this half. Sorry. This half is closer. This half is closer. And this half is having summer. This is winter. When you'll reach here, this half is closer. We'll have summer. This is winter. Now, so the the orbit is, it is not this distance which is deciding that the whole earth is cold or the whole earth is hot. The change in weather is happening due to this tilt. One half is receiving is closer to. So this is almost like a circular path. Almost, it is an elliptical path for sure, but not as is shown in the books and diagrams कि ये elliptical path है और ये sun एक focus पे है और यहाँ पे लगता है कि इतनी its distance is too much, this distance is less, and that distance is causing the change in weather. No, it is this tilt which is causing the change in weather. Okay. Now, obviously, there is this revolution also going on. So, revolution, but the tilt is more important part, which decides which half will have summers and which half will have winters. Okay. Now, coming back to quickly, four important things to the chapter. Universal law of gravitation. If there are 2 point masses, m1 and m2, placed at a distance, this is a standard thing which everyone should know. M1 and M2 will exert a force of attraction on each other, and that is given by universal law of gravitation. What is that? The force magnitude of attraction will be equal to G M1 M2 upon R square. Okay. Universal law of gravitation, it is called. Perfect. If R is the distance between. Similarly, in electrostatics, you will have Q1, Q2, two charges, point charges, and they are placed at a distance R from each other. You will have some proportionality constant will be different. This will be different. So they will exert a force of attraction or repulsion on each other, and the magnitude will be some constant, and that constant is 1 upon 4 pi epsilon naught K, where Q1, Q2 upon R square. Okay. Both the chapters will have similar terms. Now, how do you define? Now, let's come to gravitational field. What is the meaning of gravitational field? G. Or what is the meaning of electric field? Okay, explain. The amount of, if a test mass is kept at any position in space, test mass. If I place a test mass here, here, what is the meaning of that? The force acting per unit mass on a test mass. So the force, suppose this is a test mass. So the quality that a test mass must possess is its mass must tend to zero. It will be negligibly small point mass. Why do we take that? It's a testing mass. Why do we take it to be tending to zero? The logic should be clear to all of you. It should not impact the position of this because it is going to exert an attraction force on this. Or suppose I assume it is hanging with a string. Suppose. Now we bring a mass here to just test what is the gravitational field intensity here. So if the mass is large, it will attract it and will deflect this string, and the position will change, R will change. If R will change, the actual value that we want to know, gravitational field intensity due to this point mass at this point P, will change. So that's why we try to bring a test mass which is tending to zero so that it doesn't affect the position of this mass because of its own influence. Now, so all of you should know this logic. One. Second is gravitational field intensity will be equal to G M1 M2 upon R square divided by force acting per unit mass divided by M2. So this M2 will get eliminated and you'll have vector form में you could have written G M1 M2 upon R square. Sorry, M2 gets eliminated, Gm upon R square. So gravitational field intensity at this point P will be G M1 upon R square. If I ask you what is the gravitational field intensity at point Q, it will be G M2 upon, if M2 is this point mass. This is G at Q, and this is G at P, point P. Try to understand this. So either you define it, sometimes they say you place a mass of 1 kg, that is a wrong definition. 1 kg here and find out what is the force acting on it. Numerically, you will get the same answer, this answer or this answer. But that is not definition wise or practically the correct explanation. You have to always talk about a test mass being m naught tending to 0, and then you will say the force acting on a test mass per unit mass. So force nikali on a test mass and divided by the mass of the test mass, and that gets cancelled and that gives you the value of G. Similarly, in electric field, you will have electric field intensity. This is gravitational field intensity. This will be 1 upon 4 pi epsilon naught q1 upon r square, or q2 upon r square, depending on which point we are at. Okay. Two more, gravitational potential and gravitational potential energy. Let's understand these two also for a point mass only. If I have a point mass here, m1, and I have a point mass here, m2, they are placed at a distance r, and I ask you, gravitational potential energy. There are some confusions here. I want to clear them. And then we will also understand gravitational potential at a point. And gravitational potential energy of the system is what we talk about. It is not at a point. Now let's understand these two terms clearly. How do we define gravitational potential energy of the system? If suppose there are 2 point masses which are placed at a distance r from each other, this is a point mass m1, this is a point mass m2. Now, and I give you a photograph in which I'm showing two masses m1, m2 kept at a distance r from each other. Now, I ask you to define the gravitational potential energy of the system. How will you do that? The amount of work, understand this, the amount of work that needs to be done by an external agency, force or agency, to create this situation, configuration, this arrangement, configuration, this configuration or arrangement, that work is called gravitational potential energy of the system. Now, if I have 2 point masses in space at an infinite distance from each other, they are not exerting any force on each other, which is like, even if you assume that r to be infinity, then gm1 m2 upon r square will be 0 tending to 0. So we are assuming a case, hypothetical case, where both the masses are at infinite distance from each other. And then we can bring them closer and place them at a distance r from each other. There is another way, approach of creating the same situation. M2 is kept at infinity. M1 we have reached. M1 is here. Now, when we were bringing M1 from any position to another position, M1 we face no attraction or repulsion, and we are at M1 now. Now, M2 is at infinity. M2 is at a distance which is infinitely away from us. We will bring this mass from infinity to this point, and the amount of work that needs to be done to bring it from the infinity to this point, P, is defined as the gravitational potential energy of the system. This system of these 2 point masses. Okay. If I bring it along any path from infinity, I could have moved like this and then brought it like this and then this path. There can be another path like this. Whichever path you choose, because gravitational force is a conservative force, it will be path independent. Gravitational force is conservative in nature. Because gravitational forces, I am doing this from the basics because this clarity, a lot of children are confused about gravitational potential energy of the system. One single point mass or both the masses possess that energy. So to avoid that confusion right from the roots, I am doing this kind of explanation from the scratch. Gravitation, and this will help you in electrostatics also. Same thing. There you'll have gravitational electric potential. Here you have gravitational potential. Electric potential, once you understand that, what is the real meaning of electrostatic potential, then there are a lot of questions in electrostatics. uh, and then electricity and magnetism is also starting from there only. The potential difference defines the current flowing in a circuit. So everything is, the root is being explained to you. Please be attentive and keep paying attention. Now, whichever path I choose, I can bring it along a straight line as shown with this pink color. This straight line, I brought it like this, or I bring it along this path, or I bring it along this path. The work done from infinity to reach this point will be same. And it will be path independent because we are talking about gravitational force being conservative. It is conservative. Correct. Now, if we are clear till here, now what I'll do is I'll be uh, so the work done for a linear path along this line is very easy for me. I can use calculus. I can be at a distance, say x distance from this point. Okay. I am at a distance x from here, this position, while bringing it. This distance is x, and x is going to vary from infinity to this position. Okay. Now, if I want to find out the force acting on it will be in which direction and how much, the force acting on this point mass will be towards this, in this direction. They are attracting each other. So the force which M1 is exerting on M2 is in this direction. And that force is gravitational attraction force. And that force is F1, suppose. Value of F1 is gm1 m2 upon r square. Okay, correct. Upon x square. X is this distance. Now, if I leave it like this and I allow it to get attracted, it is having an acceleration, it will keep accelerating. And if it will keep accelerating, so it will come closer and closer and keep gaining velocity. But I do not want it to keep gaining velocity. I want it to come slowly and reach this position and stay there at rest. So for that, what we need to do is we need to apply an external force in opposite direction so that it doesn't accelerate. And that force we have to apply. हमें तो कुछ काम करने, we don't need to do any work at all, because if we, this mass should get attracted due to the gravitational pull of it, and it should keep accelerating towards it in this direction, and it should on its own come. Where is the question of we doing any work? But we have to do a work on this, because if we don't apply this external force, which is equal and opposite to this will keep accelerating and keep gaining velocity, and it will not come to rest at this position. We want it to be at rest and positioned here without any velocity. So we do not want to accelerate it. Because we don't want to accelerate it, we are exerting an external force which is equal and opposite to the magnitude of this force of attraction. So external force magnitude will be same as this, but direction will be different. Direction will be in this direction as shown in the figure. इधर लग रहा है वो external force. Now, we have defined the amount of work that needs to be done by an external force to create this configuration. यानी कि ये जो external force का work done है, that is what we have to calculate. Now this will explain to you all your plus, minus, everything. Now see this. If we have to find the work done due to this, we know the magnitude. For a small displacement dx, if this moves dx, this displacement I'm assuming to be dx. Then the force is acting towards right and dx is displacement vector is towards left. So what is the work done? Work done will be F external force dot displacement. This is dW. And because the force is going to vary with x, as x changes, force will change. So we will have to integrate it and put the limits infinity to r. This will be total work done. Okay. Now, if we want to simplify this, this will be magnitude of F external into magnitude of dx into cos 180. This will come out to be G m1 m2 upon x square. Cos 180 is -1. And this magnitude of dx, you have to be alert about this. Dx is a decreasing thing or not? ये सब आपका math strong होगा. If you are strong in your maths, you will realize that dx is decreasing. So dx will have a negative sign. So modulus of a negative quantity is minus dx. So it will become g, it will become plus g m1 m2 upon x square into dx. This will be your integral. You will integrate it. Finally, your answer will be minus g m1 m2 upon x limits infinity to r, and this will be your work done by the external force, and this will come out to be minus gm1 m2 upon r. This is your formula for gravitational potential energy of the system. So work has been done by an external agency, and this much work has been done. Now, this is the gravitational potential energy of the system. Now, can I ask you a question? This gravitational potential energy is the energy of M2, true or false? Or is it the energy of M1, or is it the energy of the system? I'll write down. There is M1, M2. M1 was fixed here. M2 was brought from infinity to this point, and this much work was done. Now, my question is, first statement is, this potential energy, gravitational potential energy, is the gravitational potential energy of M2, of M1. This is gravitational potential energy. Third is of the system, M1 plus M2, this whole system. This energy belongs to the system. And fourth, can't say. Please tell me what is your answer. Correct. Correct. Good. So reason, if we do the reverse, if we keep this fixed here and bring it from minus infinity to this point, still the answer will come out to be same. Or if we bring both of them together, still the integral will come out to be same. No, correct, correct, correct. You are clear about it. Very good. So this confusion should not remain. Now, what happens? There is a mass 1 kg and there is another mass 2 kg. This mass is fixed here, fixed. And this 2 kg mass is getting attracted and this distance is say 10 meters. And it is in space. There is no gravitational attraction. Only these 2 point masses exist in this universe. Will there be a force of attraction on this 2 kg mass? Yes or no? It will be. My question is, when I leave this point mass from rest, its initial velocity was 0 and it was left. It started getting attracted. When it was getting attracted, due to that attraction, it started accelerating towards it and it kept on gaining velocity. When it reaches the midpoint, yani ke it is at a distance 5 meters. What is the velocity of this 2 kg mass? 1 kg is fixed. What is the velocity? Quick, tell me the answer. Hmm. What is the velocity? 1 kg is fixed at that position. It is fixed rigidly at a given position. 2 kg mass is in space 10 meter away, left at rest. It starts getting attracted and due to that attraction accelerates. When it reaches the midpoint, yani ke halfway, what is the velocity of 2 kg mass? Quick. Can I write energy conservation, gravitational forces being conservative in nature, there'll be no loss of energy. So the gravitational uh, potential energy is here it is, here it is. At this position, gravitational potential energy is minus G 6.67 into 10 to the power minus 11, whatever. G M1 M2 upon 10. This is the initial potential energy. Final potential energy, gravitational potential energy is the change in potential energy is change in physics for anything, whether it is velocity, acceleration, energy, whatever. Change is always final value minus initial value. So change in potential energy of the system, change in potential energy will be equal to final value minus initial value. Okay. It'll be which is 1 by 2. So it'll be minus G by 5. Okay. This is a constant. This should be equal to gain in kinetic energy of the system. Only this one is gaining velocity. So we'll write this should be equal to half m2, which is 2 kg into v square. This will give you the answer. How many of you understood it? Now here, you associate this gravitational potential energy with this 2 kg mass and solve this question. But again, be careful and clear that we were talking about the potential energy, even though because this position is fixed and if we associate this whole energy with this 2 kg mass, the difference in energy will come out to be the same. Whether you mention it as a system potential energy or you mention it as potential energy of this, The answer comes out to be same, but you should always be crystal clear that this and this, they were the gravitational potential energy, not of only M2, not of this 2 kg mass, but of the system. Yes, good. Now, I have seen these kind of questions you can easily find in gravitation, but framing such a question in electrostatics, where they give you questions like a charge of Q1 2 plus 2 coulomb is getting attracted by a charge of minus 5 coulomb. They are at a distance of 10 meters and they attract each other and they exert a force of attraction on each other. Opposite charges attract each other. And when they have come closer, mass is 2 kg, mass is 5 kg, they have come, the distance between them has become, say, 5 meters. At that moment, what are their velocities? So, framing such a question in gravitation is okay. But in electrostatics, you can't. Actually, it is conceptually wrong. Please understand why. Because they are attracting each other, they are exerting a force on each other, they are accelerating, and accelerated charges produce electromagnetic radiations. Accelerated charges. और इसमें लोग वो लगा देते हैं produce, must produce. They produce EM, electromagnetic radiations, which is energy. So energy loss होता है. But people form questions, and you will find those questions everywhere. You cannot frame such questions in electrostatics because the moment a charge is accelerated, it produces electromagnetic radiations, yani कि it is emanating energy, and you can't apply energy conservation in such cases. So now let's do this question. I have, for gravitation, it's easy. And if you ever, someone gives you a question and using electrostatics, and I've seen in a lot of books, he has to mention, neglect loss of energy due to electromagnetic radiation. If he has not specified that, you cannot frame such questions, you cannot have such situations and use energy conservation. Now, let's do this question. Interesting question. Again, a 2 kg point mass, a 5 kg point mass. Initially, they were at rest and they were in space and at a distance of 10 meters. I left them free. After some time, this would have reached here and this would have reached here, and they have some velocity towards each other. The velocity of this is v1, the velocity of this is v2, and the distance between them has now become 5 meters. Half the distance has been shorter. You have to tell me. I can ask you, what is the displacement for one? x1. I can ask you, what is the displacement for 2 from its position? Suppose it has moved x1. What is x1? It has moved x2. What is x2? Third is find v1 and v2. Quick. Try to do this. Easy question. You should be. Try. I'm taking a 1 minute break. Just try this. Let's see. Hmm. What all we will do? Can I conserve linear momentum of the whole system? If I assume both the point masses, yes or no, as one system, this and this, they exerting a force on each other will be an internal force. There's no external force. Can I conserve the linear momentum of the system? Yes. So initially the linear momentum was 0 plus 0. Both were at rest. Finally, it is 2 into V1. I am assuming right direction to be positive. Minus 5 into V2. This is conservation of linear momentum. One equation. Can I conserve energy? Yes, gravitational forces are conservative in nature. Conserving energy, gravitational potential energy change. How much? Quick. Initial potential energy is minus G m1 m2 upon 10. Final is minus G m1 m2 upon 5. Change in potential energy will be final minus initial. You will calculate that delta P E potential energy. Change in potential energy, final value minus initial value. G is a universal gravitational constant. You all know the value is equal to half m v1 square plus half m2 v2 square. You solve these two equations and you have two unknowns v1 and v2. You will be able to solve. How many of you understood this? Give me yes. Okay, good. Now, increasing the level of interest, asking you some interesting question. Please be attentive. If there is a block here and it is kept on the table, this is a table, this is M mass. There is a contact force between these two. There is a gravitational force. Mg, there is a contact force. I hope I have already discussed it with you. If I say this is the action force, the contact force acting on the table, which is the reaction force? Is this the reaction force? Yes or no? Upper N1. If I say this is the action force, suppose I say this is action, will this be the reaction force N1? True or false? Just true or false? Aram says false. Let me see others, what they have to say. No, I'm saying one contact force is the action force. So the other contact force, which the true. Okay, Aram, यहाँ पे you made a mistake. True. Okay. Aram got it. Hmm. It is true. Hmm. Good. If I say this mg is the action force, where is the reaction force? Where is the reaction force? Where is it? Hmm. आदर्श तिवारी, यू आर रॉन्ग. They are action reaction pair. The force, this force was exerted by the block, exerts this N1 on table, contact force. This N1 table exerts a pushing force equal and opposite force exerts on the block. Everyone has to be clear. This, if mg is the gravitational force which is downwards, where is the reaction force for this? It can be an objective question in your exam. Yes, correct. Hmm. Nice, Aram. Good. Okay. Okay, got it. Hmm. Hmm. Earth. The center of mass of the Earth. So the reaction of this force, if this is action force, which Earth exerted on this block, the block also exerts equal and opposite force on the center of the Earth. M, same force, this force. And that is the reaction force, which is acting at the center of the Earth. All of you should know this. For mg as the action force, the reaction force is at the hmm, no. The value of g, if it is a shell, spherical shell, or rather any, so we learned to find gravitational field, potential energy for point masses. If we have a continuous mass distribution, sorry, I was eating something. You can have a linear mass distribution, you can have a circular distribution, you can have a spherical distribution of mass. If you want to aerial or volumetric, huh? If it is a linear distribution of mass, sorry, now I'm done. Hmm. And if suppose I tell you, what is the force between an infinitely long wire of mass per unit length is lambda. This is linear density of mass per unit length for this wire is lambda given to you. And I have a point which is at a distance d naught and it is m naught, mass. If I ask you what is the force acting between this wire and attraction force, so the wire will be exerting a net attraction force on this point mass. What is the value of that force? How many of you can do that? 2 lambda m naught upon d. Yes, integration you will use. All of you should know this. Go to a general position x, y. Sorry. Break this wire into a small point mass, dy length. The mass of this element will be mass per unit length into length of this element. This is the mass of this element. We will treat this element as a point mass because this element dy is tending to 0. And we will find the force between this and this. Then we'll find out this force G m naught dm upon root of y square plus d square. Then you will break this force into two components. One will be towards this wire, one will be perpendicular to this. And then when you will integrate, integration is algebraic addition. So you will realize for every element on this side, there is a corresponding element this side, and this component will get cancelled. So net force will come out to be this side, and all these derivations are standard derivations are given in your books. So for this, what is the result? 2 lambda 2g lambda m naught upon d naught. 2g. G is a misprint or what? 2 lambda. Is this the result you typed? Huh. So all these standard results should be on your tips for mains and advanced. Sometimes you may be given this integral limits minus infinity to plus infinity. Then it is an infinitely long wire. If suppose I tell you it has a length L1 here and L2 this side, and you find the net force. So in that integration sign, you will be putting in limits instead of minus infinity to plus infinity, you will put the limits L1 to L2 and integrate, and you will get the result. Get these results on your tips. Standard results. What is the uh, attraction force or gravitational field at this point due to this infinitely long wire? So you have to learn these. Now, one very interesting result which comes infinite sheet, areal distribution, and volumetric में spherical distribution. This result I want every child to be crystal clear about, and this is needed everywhere. So if m is the mass of this, r is the radius of this shell, and it is a hollow spherical uniform shell. Hollow spherical shell and uniform. Its mass distribution is also not ajib, uniformly distributed. The standard result that you need to remember is for all the points outside this shell, outside and surface. And then there is a zone called inside. So for all these points, outside or on the surface, you can assume the whole mass to be concentrated at the center and treat it like a point mass, this whole shell. So suppose I place a point mass here, I want to find the force of attraction repulsion. I don't need to use the calculus part because this whole thing has been derived. This result has been derived using calculus only. And we know the standard result. So we'll treat this whole shell to be the mass to be concentrated at the center for which points? For outside points and for points on the surface. Whether you want to find gravitational field intensity or you want to find potential, whatever you want to find, gravitational potential, both you will treat the whole mass to be at the center and treat it as a point mass and calculate. So what will be the potential on the surface? Gm upon r. This will be the potential on the surface. Okay. Now, for points inside, this is a result which every child should know. For points inside, everywhere G value, gravitational field intensity is 0 due to this shell, it will have no influence, no force inside. And we arrive at this result using integration only, calculus only. And then there is a thing, similar thing to prove this in electrostatics. You have Gauss theorem, and you can have a Gauss theorem in parallel for this also, gravitation also. Now, coming back to for inside points and potential inside is same as that on the surface. So Vs is same everywhere, and G is potential is a scalar, G is a vector, G is 0, and gravitational field intensity and potential inside at every point is same as that on the surface. And on the surface we just calculated. If you have understood this result, I want you to answer this question. I have two shells, hollow shells. One, second shell, two, and they have concentric shells. They have their center, common center. And the radius, this radius is R1. This radius is R2. Mass of the shell is M1. Mass of the shell is M2. If I ask you, what is the, there is a point which is at a distance x from the center here. This distance is x. At this point, you have to tell me what is the value of gravitational field intensity and what is the value of potential at this point, P. Please try to do this quickly. Using the result that we have just learned. We just learned this. You will do superimposition. You will find due to both the shells and tell me the answer. Tell me the answer quickly. Gravitational potential at this point due to this shell, M1. How do I find it? Is this point P lying outside M1 or not? Outside this shell. So for M1, we can assume the whole mass to be at the center and find the potential here. So potential due to M1 at point P is treated as a point mass at the center because this point is lying outside the shell. So minus G M1 upon X. If I want to find the potential due to M2, what is the potential due to this shell inside it at every point? Same as that on its surface. What is the potential of M2 at its own surface? For surface, you can assume, for surface or outside the surface, you can assume the mass to be at the center. So M2, you will write minus G M2 upon R2. This is R2, sorry. So the potential due to this shell is same as that on the surface. On the surface, this is the potential. So we say for every point inside, the potential has to be this. So these two potentials when added will give you the answer, total potential at point P. Superimposition theorem. If I want to find electric field here, electric field intensity, gravitational field intensity, and the same things you will have in your electrostatics chapter. So please, all of you, learn these things clearly and your life will be very easy after that. Now, for this point, Can anyone answer this? Now I'm expecting you to answer. What is the gravitational field intensity at this point? Minus G M1 for this shell. It is lying outside, so you can assume the whole mass to be at the center and find G. G1 due to this shell, G1 will be towards attraction, towards the center, and it will be G M1 upon X square. Okay, magnitude directed towards the center. G2 due to the outer shell. What will be the gravitational force, gravitational field inside the shell? Zero. So the total gravitational field inside the shell at point P will be this vector addition of these two, and that is G M1 upon X square, and potential will be this. How many of you know this? How many of you have understood this? Or you know this, whatever is the case. I'm okay with if you already knew it or you have understood it now. Please give me a yes. Those who know it. Okay, good. ठीक है. So if you know this result, now let's do some interesting questions of electrostatics based on this result itself, and you will learn few things there. This is a shell. Chalo, let's do an interesting question. Thin shell. There is another shell, concentric shell, and this inner shell, or say this outer shell is earthed. I have given a charge 2 coulomb, 2 coulomb to this plus 2 coulomb for this inner metallic shell whose radius is 1 meter, and you have to tell me what is the charge distribution of on all the four surfaces. So for a conductor, however thin is the shell, however thin is the conductor, it will always have two layers: inner layer, outer surface. Do you know this conductor thing? If you ever have any conductor, jahan jahan pe, suppose this is a cavity, and here you have conducting material. Suppose ये iron or any other copper का solid वो है, और यहाँ अंदर जो है ये वाला part is cavity. This is cavity. Now, for any metal, if you give any single electron to it, ये भी एक अच्छा concept है and all of you should be clear. Suppose I keep an electron. Wherever you keep that one single electron in that metal, it'll stay there, won't move. It may do Brownian motion, but it'll be like zigzag there only. It will not be drifting or shifting or going anywhere. Suppose I give 2 electrons to this metal, they will try to repel each other, 2 electrons. So 1 electron, and they will try to go as far as away possible from each other. So they will be like this. Just giving you a layman's explanation. Now, so this electron will repel this electron and try to stay as far as possible. Suppose I give it 3 electrons. They will form a kind of triangle, repelling each other maximum. तो ये थोड़ा यहाँ आ जाएगा, जिससे कि they are at the farthest possible distance from each other. Now I give 4 electrons, they will form a kind of symmetrical situation so that as far as possible they stay from each other. Now if you give millions of electrons, they distribute themselves in such a way that they are on the outermost surface, trying to repel each other, trying to stay as far as possible, and the charges distribute themselves on the outermost surface in such a way that the potential is minimum. Okay. To minimize the potential. Okay. Let's see. Now, my question is, can you tell me, suppose this is layer one, inside layer of the shell, layer two is outside layer three is inside, and layer four is outside. Can you tell me what are the charges on? I gave 2 coulomb charge to the shell, inner shell, and then placed under the shell outside, and I have earthed the outside shell. Tell me on each layer how much is the charge? Oh, can you do it? Have you heard of Gauss theorem? Have you done Gauss theorem? Most important. I'm sure you must have. Gauss theorem says that the charge enclosed, the electric flux passing through a surface is equal to the charge enclosed by the surface upon epsilon naught. Now, all of you know that the electric field inside a metal has to be zero and potential has to be same everywhere. So the potential should be same. And now, can you tell me what is the charge on 1, 2, 3, 4, these layers? Inner layer of this sphere, outer layer of this sphere, inner layer of this sphere, hollow sphere, metallic, and outermost surface. Please tell me what will be the charges? What will be the charge distribution on these surfaces? Can anyone tell me? Okay. Is there anyone who can? Um, I just read your chat. Okay, good. That's a good idea. ठीक है. I just read that. Sorry, little late. Hmm. चलिए. Good suggestion. Now, while solving this question, you need to know Gauss theorem, and I'm expecting that all of you know that. Whenever there is a metal will always, however thin it is, even if I tell you it's a very thin metallic shell, it will always have two surfaces, and those two surfaces are the inner shell, the outer shell. This is the inner surface, this is the outer surface. Now, this is the inner surface, and this is the outer. This is the inner, this is the outer. ऐसे कर लेते हैं थोड़ा मैं. I am showing it as a thick material just to give you clarity. Now, I want to find, let me assume the charge inside is X. So the total, this spherical shell is isolated. This spherical shell is given 2 coulomb charge. If it is X here, outside it will be 2 plus X. Now please tell me, what is the value of X? Can I say that the metal, any point inside the metal, suppose this is a point which is inside the metal between the two surfaces. At this point, what will be the electric field intensity? Zero. Because inside a metal, electric field intensity is always zero. Now, if I make a Gaussian surface and I use Gauss theorem inside the metal and have a closed Gaussian, I need a different color, and make a closed Gaussian surface inside this metal. At every point, I know electric field intensity has to be zero. So E dot ds for this surface, which is the total flux, will be 0. If that is 0, the charge enclosed must be 0. Therefore, x should be 0. So the inner surface will have 0 charge. If it has 0, you have given it 2 coulomb, outer surface has to have 2 coulomb. If it has plus 2 coulomb, the inner surface has to have minus 2 coulomb. Why? Again, use Gauss theorem here. Gauss theorem, inside this metal, draw a Gaussian surface, which is an imaginary surface inside the metal, and use E dot ds for this Gaussian surface. This one, you will have again electric field is 0 at every point inside a metal. So when you will do E dot ds, you will get electric flux by E dot ds method. You will get it 0, and that should be equal to Q enclosed upon epsilon naught. Now, Q enclosed has to be 0 inside this shell, this imaginary Gaussian surface. If it has to be 0, if it was 2 here, it has to be minus 2 here. Now, when you have connected a shell to Earth, Earth is an infinite reservoir of charge. It can take or give any amount of charge to the body, provided the body maintains its potential to be 0. So if we want the potential here to be 0 on the outermost surface, you will realize that the charge has to be 0 outer surface. So the distribution, final distribution of charge, the answer is on surface 1, the innermost surface of the shell, you have 0 charge, then you have plus 2, and you have minus 2, and you have 0. Now let's reverse the question. Now you do it. I have given you the explanations for the first part. I am giving you two shells. One is radius R1, another is radius R2, and I am giving you this inner shell is earthed to the ground, and outermost shell is given Q charge. It is given Q1 charge. Now you tell me what is the charge on surface 1, surface 2, surface 3, surface 4. There is one catch that at the center there is a point charge also kept, which is Q naught. This is also there. You have to tell me the surface charge, the charge on surface 1, 2, 3, 4. Quickly do it. Here we have two charges. One charge is at the center, the other charge Q1 is given to the outermost shell. Is given to this shell, outer shell. Inner shell is earthed to the ground. Tell me what will be the charge distribution of on 1, 2, 3, 4. Inner shell minus 2Q. Sorry. Inner of shell 1. Aram. Why should it be minus 2Q? It should be, here it will be, this is Q naught, point charge. So it will be minus Q naught here. Minus Q naught. Why? Because this shell, however thin it is, it still has two layers. And if I make a Gaussian surface inside it, which is imaginary and closed, E dot ds for this surface will be 0. Therefore, charge enclosed must be 0. So if this is Q naught, this has to be, on this surface, it has to be minus Q naught. Get this. How many of you understood this, that it will be minus Q naught on the inner surface? Say yes. If it is minus Q naught, okay, sorry, I just read it. Okay, in this case, it will be minus Q naught. Here it will be, it is earthed. Can anyone tell me if it is Y here or X here? It will be minus X here, and it will be Q1 plus X here. Now, can you tell me how do I find the value of X? So we are clear about inside. At the center, you had a point charge, which was Q naught. So the inner surface of this shell will have minus Q naught. Reason? Gauss theorem for this Gaussian surface. If this surface, which is Earth, acts as an infinite reservoir of charge, and it is Earth, so obviously x can have any value. We do not know that. But if it has x, it has to have minus x. Why? The inner surface of this outer shell. It has to have minus x because, again, this outer shell, I'm making it a little thick for you to imagine. And the Gaussian surface inside this shell will ensure that inside the metal electric field is always zero. So E dot ds for this shell has to be zero. So the charge enclosed has to be zero. So if it is zero, if it is x here, it has to be minus x inside. And because the outer shell is isolated, so the charge has to be conserved. So Q1 plus x has to be here. How do I get the value of x? Who can do it? Aram, how do I find the value of x? We will make the potential of this shell zero because it is earthed. So let's find out the potential due to all the charges. You can assume this charge to be at the center. You can assume this charge to be at the center. देखिएगा. You can assume this charge to be at the center. It is already at the center. Minus Q naught placed at the center, they both nullify each other. Okay. What is the potential due to this charge on this surface? Potential due to this charge will be K, 1 upon 4, K. Potential is how much for a shell? 1 upon 4 pi epsilon naught x upon R1, Q upon R, as that on the surface. What is the potential due to this charge on this surface? Due to this charge, it will be potential is same as that on this surface. So you will have minus x upon R2. And for this, it will be when you solve this, you'll get the value of x, put it equal to 0. The potential has to be 0 because it is earthed. Potential on this surface has to be 0 net due to all the 4 charges. 1, 2, 3, 4. All the 4 layers will produce net potential to be 0 at the center. And you will get the value of कितना आएगा? ये x, sorry, q1 plus x, and this is minus x. Sorry, I forgot this minus sign here. Okay, so this gets cancelled. X upon R1 plus Q1 upon R2. X is equal to minus Q1 Q R1 by R2. This will be the answer. And you will know the distribution on all the 4 surfaces. Okay, children, I think uh, too much of monologue and too much of lengthy conceptual derivations, theory, which I've been teaching, but because I know, Arham. Okay, correct. Good. So I have not gone too difficult because I want to ensure that you are knowing the concepts which are very important for J mains at the moment. So I'm intentionally not doing very tough problems, which will involve a lot of uh, deep concept and calculations. So right now I have stuck to just ensuring that I am trying to cover the key concepts which all of you should know. So in the next class, we'll see the remaining part. Oh, we can do the class is till what time to what time? Can anyone tell me? It was up to 7 or 7:30. I can do Kirchhoff's rules quickly or do something else. क्लास वाज टिल 7। ठीक है, चलिए, we'll meet in the next class and we'll try to do some interesting concepts uh, related to your JEE mains and NCRT level. So I'm not trying to go beyond that because right now you will be appearing for your mains exam and I'm trying to cover up the concepts for that. ठीक है, चलिए, thank you so much, all the best, take care, bye children, bye bye.